Today we're going to talk about quadratic functions, which is in section 5.1 of your BJU Press Algebra 2 textbook. And we're going to look at things like domain, range, maximum and minimum values. We're going to look at the graphs and parabolas, and how to graph a quadratic function by plotting points. So let's first talk about how when we studied linear functions in chapter 3, we used our knowledge of linear equations to help us with linear functions. So we're going to do the same thing for this. We're now studying quadratic functions, but we're going to use all of our knowledge from chapter 4 when we studied quadratic equations. We're going to use all of that information when we study quadratic functions. So let's begin with talking about what is the difference between an equation and a function. So when we were talking about linear, a linear equation had one solution versus a linear function that had an infinite pair of solutions that formed a line. Because when you had a linear function, you had two variables, so you could plug in an infinite number of x's to get an infinite number of y's, which gave you an infinite number of points that when you looked at it, it became a line. That's how they got the word linear. So the main takeaway on equation versus function is equation is going to be one variable versus a function is going to be two variables where the one variable depends on the other. So let's look at linear versus quadratic. In linear, if we had a linear equation, it would look like something like 2x plus 3 equals 7. So notice how I could solve for x and I would get one solution. Versus a linear function, which is like 2x plus 1, y equals 2x plus 1. So notice that there are now two variables and the y depends on the x. So that's how we now have a linear function. And then the graphs of linear functions typically are going to be a line. So like here. So when we're talking about quadratic, a quadratic equation has this general form, ax squared plus bx plus c equals 0. It's the general form. So an example would be like 3x squared minus 5x plus 8 equals 0. But when we start talking about a quadratic function, we're going to introduce our second variable y that needs to depend on our quadratic equation. So we'll have y equals x squared minus 3x plus 1. That would be an example of a quadratic function. So our question is that what does the graph of a quadratic function look like? So what we want to do is we're going to plot some points on a coordinate plane after building a table, and we'll see what a quadratic function typically looks like. So we are going to do y equals x squared plus 2x minus 15. So I'm going to make a table. I'm going to plug in x values and get y values. All right, so I would like to start with -4. So when I plug in -4, I get -4 squared plus 2 times -4 minus 15. And if I do the math on that, that's 16 plus -8 minus 15, and that gives me -7. So now I'm going to plug in another value. Let's do -2. So that's -2 squared plus 2 times -2 minus 15. So -2 squared is 4, minus 4 minus 15. So that's going to be -15. All right, so now let's try 0. So 0 squared plus 2 times 0 minus 15 gives us -15. let's go ahead and try 2. So 2 squared plus 2 times 2 minus 15. So that's 8 minus 15. That gives us -7. All right, and let's try 4. So 4 squared plus 2 times 4 minus 15. So that's going to be 16 plus 8 minus 15. So that means that we'll get 9. All right, so let's go ahead and plot the ordered pairs that we got. So -4, -7. Then we have -2, -15. And then we have 0, 15. And then we have 2, -7. And then we have 4, 9. All right. So if we were to connect these points, so I see right now that I have -2, -15, and I have 0, -15. So my question is I wonder what -1 would be, right? So let's do -1. So -1 squared plus 2 times -1 minus 15. That would give us -16. Okay, which kind of makes sense. That means it's right here. Okay, so now if you look, it looks like my graph is kind of curving down and then curving back up. And then it also looks like after this point right here, it's almost like when it goes back up, it's matching. Like you see how it has an equal amount. So we just sketched our first graph of a quadratic function, and it is a curve, right? So this curve that a quadratic function that represents a quadratic function, we call that curve a parabola. Okay, so a parabola. The parabola is the curve that represents a quadratic function. So just like a line represented a linear function, a parabola is the curve that represents a quadratic function. Okay? So in function notation, a quadratic function can look like this. Y equals x squared plus 2x minus 15. Okay? But remember that y and f of x mean the same thing. So we could have also had something like this. F of x equals x squared plus 2x minus 15. And then also, if our general equation, remember our general equation for a quadratic equation was ax squared plus bx plus c equals 0. But if we want our general equation for a quadratic function, it's going to be a little different. Instead of being equal to 0, it's going to be equal to y. So y equals ax squared plus bx plus c. And if we want to put that in function notation, we just replace y with f of x. So now we have f of x equals ax squared plus bx plus c. And so this is a general equation for a quadratic function. So let's talk about some distinguishing features of a parabola. Okay, so a parabola is a curve, right? And so we talked about a little bit how the parabola kind of went all the way down and then it stopped. So I'm going to graph a new parabola here that we're going to look at. Okay, so here we go. So notice that this parabola has a lowest point. You can also have a parabola that looks like this. And this parabola has a highest point. Okay, it has a highest point. It's actually supposed to be right there. So it would come out a little bit more like this. Sorry. Okay. So we have, so ignore this piece. This is not supposed to be there. Here. There we go. All right. So we have one parabola with a lowest point, and then we have a parabola with a highest point. So these lowest and highest points, we call those the vertex of a parabola. So the vertex of a parabola is going to be the smallest value or the largest value of y. So the smallest or largest value of y. Okay? Because it represents how far up and how far down it will go. So because we have a smallest or largest value, we can also call these minimum and maximum points because they are points. So if you have a smallest value, you're going to have a minimum point. If you have a largest value, you're going to have a maximum point. So again, the smallest and largest values of y are also the minimum and maximum points. All right, so remember we looked at when we graphed this one by hand, we also noticed that there was matching going on. That matching that we found, that we looked at, that's what we call symmetrical. So parabolas are going to be symmetrical. They look the same on both sides of a certain line. That certain line is what we call the line of symmetry. So for example, in this graph here, my line of symmetry would be this line right here. And since it's a vertical line, it's the line x equals something. So this is x equals 1, 2, 3, 4. X equals 4 is the line of symmetry for this particular graph, line of symmetry. So line of symmetry is where your parabola begins to be symmetric, okay? All right, so now let's talk about how this can also be the axis of symmetry. So line of symmetry and axis of symmetry is going to be the same thing. All right, let's now talk about domain. So the domain of a quadratic function is always going to be the same no matter what quadratic function you have. The domain of every quadratic function is going to be all real numbers because you can plug in any x value. However, the range for a quadratic function is going to depend very much on the vertex. If our vertex is represented by the point hk, so remember k is the y value, so that's going to be the highest or lowest point that it can be. So because it's the highest and lowest point, the k is going to make the difference in your range because range depends on the y, all right? So you're either going to have, depending if it has a minimum or maximum point, if hk is a minimum point, then your range, so if it's a minimum, that's the lowest it can be, right? If it's a minimum, that means your range is going to be all the y values greater than that k value. So all the y's greater or equal to k. If you have a maximum point, remember the maximum point is the highest it can go, well that k value, all of your y values have to be smaller than that k value. So that means y, for the maximum, your range is going to be all the y's that are less than or equal to k. All right, so in our chapter 5, we're going to study more about quadratic functions and their graphs, and then we're going to take that and even be able to take it further into higher degree polynomials. But for now, go ahead and try some problems on your own from 5.1.